Okay, let's have a look at that question, which is very similar to yours. Let me explain that one, and then you can do the question in your assignment. So that's to do with the task 3. So we got a tank here. It's drained by this pipe. So this is 1, this is 2. First position, second position. We need to find the pressure head at this point when this is closed. So the flow rate is reduced to 20 decimeter. Okay, decimeter. In 1 meter, there are 10 decimeter. In 1 meter cube, there are 10 decimeter cube. Yeah, that's the unit conversion. Okay, pressure loss is equal to 2 meter head. Let's have a look. Let me just get rid of that bit. Enter. That's it. Okay. Let's have a look at that question. So we have a diameter of that one, which is 50 millimeter. Diameter of the tiny pipe is given 50. On here, on the top, that part on the top, this is a free surface. Yep. So we say like H1 is 0. We need to consider the equation. If you remember the equation, let me write the equation first and then we proceed. So first we got the Bernoulli's equation. Bernoulli's equation of the head, it's the stage 1, stage 2. Yeah? The inlet should be equal to outlet. The total energy on the inlet at point 1 should be same as the point 2. So whatever the energy here should be same on the other side. So H1 here and H2 here. That's the head losses. Yeah, H is not the height. Z is the height. Yeah, Z1 here and Z2 here. Yeah, plus. Now the next one is a kinetic energy, but we divide everything by mg, so that a lot of things cancel out, and that is v1 square over the 2g. I write v1 rather than u1. Yeah, v2 square over 2g. So this is what I got. One other thing I miss is the head. Yeah, this is H1. Now there's another one. I'm going to do HO. Rather writing that one, I can't call it HO plus H. Rather O, I call it H1. Then I call it H2. Yep. Okay. Now let's put the values and find the answer straight from this question, straight from that one. Okay. According to the question, the H1 is 0. So that's I put 0. Z1 is the height. Z1 from here to here, the height, which is 15. Okay, done. Now let's see. Do I have the velocity? I don't have the V2 is the velocity. I don't have the velocity, so I ignore that one for a while. And over 2g, I know 2g is a 2g. I need to find this V1. I do that one later. Now the other thing is the head for that one, it's going to be 0 as well, plus another 0 on this side. Now I need to find the H2. Find the pressure head at point 2. H2 is the one we're trying to find out. Z2 is called datum line, D-A-T-U-M, datum line. It's 0. It's at the surface. So Z2 is the height from the surface, which is 0. 2G is here. H2 is given, the big H2 is given, which is 2 meter head. Yeah? So I write that one a 2 there, that H2 is 2. Now I don't have the V1 and velocity 1, and I don't have the velocity 2. If I find these two velocities, here and here, and I can put that one, and everything will be sorted, and I can find the equation. Let's solve this equation a little bit more before we just put that one. So H2 is the one I'm trying to figure out. So that H2 is there. On this side, I just got 15 plus something over a 2G. Let me rub this H2 and just put it across here. That's what we're trying to find out. If I move this thing on that side, yeah, remember that was V2 squared and that was V1 squared. I need to find this value and then put it there. And this 2 goes on the side, becomes a minus 2. So I need to find these two values and then I put that one. So let's try to find the V1 and the V2. Let's go back to the question. The question says the flow rate is reduced to 20 decimeter per second. So that is the flow rate. Yeah. First thing I need to do is I need to convert 20 decimeter cube into meter cube. So 1 decimeter cube is 10 to the minus 3. Yeah, meter cube. So I got 20 decimeter cube is 20 times 10 to the minus 3. Yeah, meter cube per second. Yeah, just put per second. So that's the flow rate. So now flow rate, I'm going to call the flow rate as Q. Let me see, is it the right conversion? Yeah, cube, yeah, that's right. So 20 decimeter cube per second is equal 20 times 10 to the minus 3 meter cube per second. Yep. So I got that thing done. So that's the flow rate. I'm going to call the flow rate as Q. Yeah, that's the flow rate. It's not the Q as in heat. Its flow rate is also known as a Q. So I got the flow rate. So flow rate, I converted that one. Now, I need to find out the area. I need to find out the area of this pipe. Yeah. To find that, it's 50 millimeter bore. So the area pi r square, pi is a pi, radius is 25 millimeter, convert that into meters square. That will give me some answer here. So I got that answer. When I got this answer, whatever the answer is, I need to find out, I need to use a continuity equation. The continuity equation. Now what is a continuity equation? Continuity equation states that Q equals to VA. Yeah, that's a continuity equation. So there's a continuity equation, which is a continuity. Q equals to the VA. Now I need to find out the V. So V equals to the Q over A. A is whatever that red box is. And Q is this one. Okay. So I put the value of the Q and I put the value of the A. Now I have used the second position, not the first one. I'll use the second position. So this is going to be my V2. So I will have an answer. So I'm just going to say V1. So let's see, V2 will give me an answer in meters per second. Okay, done. So I have this one. Now what about the V1? What about the V1? V1, it's 0 because this thing, relative to that velocity, the velocity of that one is going to be the 0. The area is quite large, so the V2 is very small. If the V2 is very small, let's go back. No, sorry, V2, did I say V2? V1. V1, sorry, not V2, V1. V1 is very small. If the V1 is very small, V1 over 2G is going to be even smaller because I'm dividing by 2G, so that's 0. So what I'm going to do is I'm just going to copy this equation. And then I just put the things and let's make few things 0 and now we'll get my answer. So the 15 remains here. That thing is a 0. This thing over 2G minus 2 equals to the H2. Now what should I put on this one? I need to put that green box. Yeah, so the green box here. Yeah. And then I just put my calculator and I will get my answer. That's it. Let me save the video. If that is, oh, that's very long.